All right, we're going to move on now to GJ from Tyfast to give an update on their LVO anode.
Thanks,
GJ.
John.
Yeah.
Hopefully everybody can hear me well. So GJ here, CEO, co-founder of Tyfast. Thanks to Vanatech for the opportunity to present our work today. Um, so we're powering diesel-grade batteries for heavy industry and defense, and this is built around a novel lithium vanadium oxide, or LVO anode. Our mission is straightforward: electrify sectors that move the global economy: mining, construction, agriculture, defense, heavy logistics. And the reason I'm excited to be here today is I believe this technology can create an exciting growth pathway for vanadium. Next slide. So vanadium has already transformed industries before. Steel and infrastructure first, right? Stronger bridges. We just heard from Mr. Alay Shah, right? Grid energy storage, vanadium flow batteries, creating a durable and safe long duration ESS. At Tyfast, we believe this third chapter will be heavy industry and defense. Mining fleets, heavy duty trucks, construction, defense platforms. The growth story for vanadium can be electrification of heavy industry, and we're working hard to make that future accelerated. Next slide. So, why should the vanadium industry care? Because this opportunity can create tremendous value across the entire ecosystem. So, starting with the upper left side, for producers, this creates new demand that can support more investment and expansion of mining. For refiners, upper middle there, demand visibility will support scaling of plant capacity. For technology providers like Tyfast on the lower left there, more technology deployment leads to accelerated learning curves and widespread commercialization and validation. On the financial side, so on the upper right side for traders, this means new markets that deepen liquidity and can reduce price volatility that we've seen in vanadium in the past. And on the lower right, for investors, importantly, right, large and fast-growing markets will attract more capital. Ultimately, alignment across the value chain is what transforms vanadium from a commodity into a critical energy material. Next slide. So going back to the title of this talk, right? There are still multiple sectors that remain very difficult to electrify and solely rely on diesel. Mining, construction, defense, marine, some examples there on the left. And they're all share the same characteristics. They need extreme uptime because this is what generates revenue. When they're parked, no money is created. In fact, revenue is lost. They need high power to carry heavy loads up a long grade, whether it's a mine or up a mountain, right, for heavy duty trucking. They need fast turnaround. This means faster fueling, like you see with diesel powered systems today, and importantly, long service life with asset durability for a decade or more. The battery that works in an air passenger car is not the same that will work effectively in a mine. So heavy industry needs something fundamentally different, and that's what we're working on. So next slide. So the scale for this opportunity is huge. If only 1% of the heavy duty markets adopt vanadium enabled batteries like LVO, this represents roughly almost half 493 gigawatt hours of batteries, or nearly 500,000 metric tons of V2O5 requirement. So this is about twice the current annual production for V2O5 worldwide. And this is really only 1% penetration. A key metric for everyone here to take note is 1 gigawatt hour is about 1,000 metric tons of V2O5, or essentially um, a metric ton per megawatt hour, right? That's the conversion. So even more efficient relative to vanadium flow batteries. And the table here at the bottom quantifies the breakdown for these different markets, heavy duty trucking being the largest, and defense and tactical vehicles, although being a smaller one, still a significant portion of the vanadium market today. Um, a key and important point is that these are performance markets, right? Consumers pay for essentially um, a cheap battery, whereas heavy industry will pay for uptime. Heavy industry will pay for power. Heavy industry will pay for durability. That makes them ideal in early markets for durable technologies like LVO. Next slide. So Here's what heavy industry actually needs. They don't benchmark again against passenger EVs, they benchmark against diesel. And diesel systems have refueling time in minutes. It works essentially reliably in all weather conditions. It delivers power output that's very high. It lasts for decades, and it's a very proven technology. If batteries are going to replace diesel, they're going to meet these same diesel grade requirements. So next slide. So here's why current battery systems struggle, right? They can actually already power heavy duty platforms. However, the challenge is that lithium ion batteries face difficult trade offs today, right? The consumer kind. If you want max uptime, like fast charging typically, they actually rapidly degrade battery life. So you don't get the nameplate cycle life that you have on your spec sheet. You could potentially cut that down by half, creating all sorts of issues related to battery replacements and the costs around that. To achieve high power, one has to deal with significant thermal challenges, which actually also results in shorter battery life. And to achieve long life, typically one would actually have to lower the performance of these lithium ion cells to just achieve even 1,000 cycles of cycling capability. Industrial operators don't want to sacrifice one of these requirements to achieve another. For heavy industry, they actually need all these components to be um, present, right? Or else the systems become expensive and there is essentially little to no electrification adoption. Next slide. So this is why diesel remains dominant, right? When you have long charging downtime, you create essentially unwanted stops that don't generate revenue. To mitigate this, you might want to put on, in this case, on the upper right-hand side there, oversized battery packs that actually increase weight, increase cost, reduces your overall carrying capacity. Um, because these batteries don't last too long, frequent battery replacements can increase life cycle cost, right? Increase further downtime, given that the system will have to go back to the shop to do battery replacements. And then at the end of the day, really overall productivity suffers. So the key point is simple. Battery limitations don't stay in the battery bay. They show up in the operating economics, making this transition difficult, in fact, almost impossible. And next slide. So at Tyfast, we're focused on a completely different approach, building batteries specifically for heavy duty, delivering now combined high power, fast charging in minutes, that long cycle life that's needed for diesel grade durability, and importantly, all weather capability, given that these heavy duty systems will work hottest days of summer, coldest days of winter. Consumer EVs that you guys drive optimize for range, industrial machines will optimize for uptime. And these are fundamentally different problems to solve. Next slide. So this is where I'm introducing this LVO material. This is our core technology, lithium vanadium oxide, where we enable now diesel grade performance by just changing one component. That orange portion is the anode side. You typically have graphite in your consumer grade battery. You replace that with LVO now. We'll keep the rest of the components, right? The separator, the cathode, the electrolyte, essentially the same. And the performance targets are ambitious. We can enable 10 times faster charging, so rapid charging in single digit minutes, 10 times more cycle life, so you can have operations for a decade or more, twice the operating temperature range. And this is important, especially in the cold, and full compatibility with existing lithium ion manufacturing. The key idea is simple. The anode is the enabling technology. It's LVO that is what makes this possible. Next slide. So here's why vanadium actually matters. Because its unique electrochemical properties enables the performance breakthroughs. So first, um, you have actually faster lithium transport in this LVO structure. Lithium ions can move more rapidly in this 3D crystal structure shown here on the left, supporting the high charge rates that we claim. Second, LVO actually has better structural stability. It has 5 times lower volume expansion during battery charge and discharge cycling, um, preserving many thousands of cycle life, unlike graphite, which has over 10%, for example, of volume change as you cycle. LVO actually has less than 2%. That significantly reduces chemical and mechanical damage per cycle, resulting in a longer battery life. Finally, safer fast charging. The higher operating voltage for this unique LVO anode provides a larger buffer against that issue around lithium metal plating during fast charge. Vanadium here in this case is not the additive, it's actually the performance enabler. For every kilogram of LVO, 90% of this by weight is vanadium oxide. Next slide. So here are the key performance targets that matter to industry, and Tyfast has validated this with customers in full-scale pouch cells. The picture on the upper right there is about a 8-inch by 8-inch square pouch cell over 10 amp hours that we've delivered to customers for their external testing. So the key metrics are less than 10-minute charge time to get machines back to work generating revenue, more than 10,000 cycles for industrial grade durability, uh, around 200 watt hours per kilogram. And this is key. This is now the industry grade capability, for example, for graphite LFP. We want to be equal or better than graphite LFP, which is the battery chemistry that's been chosen by industry, um, with even wider operating temperature range, right? Minus 40 C charge acceptance, which current no batteries can provide, other than lower energy systems like LTO or lithium titanate. And then lastly, the key here is we've modeled up to 50% projected OpEx savings versus diesel. Together, these combined capabilities really create what we call an uptime first performance. Next slide. So here's put yourselves in the mind of let's call it a system designer, right? Um, where now you have fast charge essentially as a not just a specification, but actually as an operating variable. So for your traditional old model, slow charging lithium ion, you may focus on putting on bigger packs to survive those long charging gaps. You probably have to plan for downtime at certain points of time in your operations, which makes it more complex, and you end up at the day with lower utilization. Moving to that new model, very fast charging, you can now right size the battery pack, lowering the cost and weight of the system. You can now charge opportunistically, whether it's on route or with regen or even with quick driver breaks. At the end of the day, it's better utilization, better productivity. And that's why charging speed in this case matters so much in these industrial applications. Next slide. So at the end of the day, heavy industry adoption only happens if the economics bear out. And with LVO, these positive economic platforms actually compound quickly. So first, top row, lower energy costs. Electric fuel has roughly 50% the energy cost of diesel on a per hour or per mile basis. Secondly, lower maintenance costs. Electric machines have fewer moving parts. They will require less maintenance. That's already been borne out in the passenger EV space. Um, Diesel grade uptime. This is an LVO based capability. We can maintain 100% of that diesel uptime that you see today in ICE systems, right? And number four is another LVO based capability, diesel grade durability. Now with 10,000 cycles, we can actually last and preserve that investment for that platform. And together at the very bottom there, number five, these electric and LVO advantages deliver about 50% modeled OpEx savings for industrial fleets. And the LVO technology is one that enables essentially strong compounding levers. Next slide. Excuse me. So for the next couple of slides, I'll talk about some applications that we're focused on. So mining is one of our higher priority markets. They're the toughest operating environments in the world for batteries. And we actually have two leading mining vehicle makers testing LVO today. Operations for mining trucks are continuous for decades, right? With underground mining actually being a really strong value proposition because you can reduce very expensive ventilation costs. In this environment, durability, safety, uptime, and at the end of the day, total cost of ownership, which is dollars per ton, matter more, right, than anything else. And this is where LVO has a strong value proposition. Next slide. Excuse me.
Yeah, grab a drink of water.
Yep. Um, Defense is another important application. And LVO has actually active engagements with US Army, excuse me, Air Force and Defense Logistics. So the first two images there, ground vehicles and directed energy systems, are all high power platforms. And this is what I already showed you earlier. LVO can truly deliver. For soldier power there in that third image, LVO with its wider temperature range can actually deliver mission-ready Arctic operations. And then the last image, LVO's unique, what we call zero volt capability, can also provide value for these long-range naval expeditionary missions. These applications shown here all demand performance and supply chain resilience. And what's unique is that vanadium can actually provide that localized and secure supply chain because it's more distributed worldwide, creating an important strategic advantage for energy security. Next slide. So I've talked about steel. I've talked about vanadium flow batteries. I mentioned this emerging use case for heavy duty in defense. When we look at the vanadium's future, we actually see another potentially really exciting growth engine. Um, and this is now powering the world of physical AI. What this means is autonomous vehicles, robots, and drones, all essentially running on an AI platform, right? These systems will be always on. Um, they will require high performance, high throughput from an energy and power perspective. They will actually have duty cycles that look like mining, 24/7 operations for a decade or more. And with batteries on these platforms, we believe LVO is in fact the unique battery that can maintain the high uptime, the high productivity that will be demanded from these physical AI systems. Again, another very exciting future market for vanadium. We believe that has a strong advantage, right, for this application. Next slide. So here's how the vanadium community can help, right? This overall kind of push towards heavy industry and then future physical AI. We can't build this market alone. We need collaboration across the ecosystem. So supply chain partnerships to show there is a secure sourcing for these critical applications will be important for us. Um, we want to do more pilot and demo projects with you if there's interest, right? To fully validate LVO and its new flavor of chemistry in the field, whether it's in your mine or your logistics operations. Um, we want to be part of industry advocacy to showcase, right? There are, in fact, new important multifaceted applications for this relatively unknown critical mineral. We believe these applications are going to be now important for national and strategic competitiveness. And that's what we want to further publicize, right? And importantly, we seek new investment and commercialization support. Today, we have LVO production capability under a megawatt hour capacity per year or under a metric ton capable of like LVO conversion. We want to move to double and triple digit megawatt hours over the next 24 months. That will require investment for scaling. What we're doing here is building more than a battery, right? We're building essentially a new and exciting demand pathway for vanadium uses in the future. Next slide. So in closing, right, if we zoom out, the progression for us, at least at Tyfast, is clear. Steel infrastructure, check. Grid storage, as we heard from Mr. Leisha, rapidly expanding in China today and potentially the rest of the world next. Heavy industry, we believe that emerging market with LVO can be a really strong opportunity that could really exponentially increase the growth for vanadium from a utilization standpoint across multiple markets. And now, right, chapter 4, powering the world of physical AI. Um, each of these chapters, right, expands the role of vanadium. Each of these chapters creates new value, and together they position vanadium as a foundational material for this future of energy and industry. Next slide. So thank you again for the opportunity to present. I appreciate Vanatech and its work for strengthening the global vanadium ecosystem, and I'm happy to take questions if there's time.
Yeah, great presentation, GJ. I appreciate it. I have a couple here that I'll read off to you if that's okay. The
Absolutely.
first one, without saying what is your optimal price, we can't do that for antitrust reasons. The question is, what is the cost sensitivity of the LVO anode to vanadium prices?
It's pretty much linear. As I mentioned, 90% by weight of LVO is vanadium oxide. So it's almost a one-to-one from a price perspective, right? At scale. Now, at low scale, most of that material price won't necessarily reflect into the final price of the product because your processing cost is probably significantly higher than that raw material cost. But at scale, when battery material costs are a majority of that final actual cost, then it'll be more linear.
Oh, good, thank you. Next one. Tyfast value proposition is built around fast charging, high power, and long service life. What validation milestones or performance guarantees will industrial customers need to see before adopting the technology at scale?
Yeah, so we're doing that at the cell level now, as shown in one of the previous slides. We need to next do that at battery pack level, where now you're building essentially this technology at a factor of 10 or 100 times larger. And we believe that will lead to a design win. And that design win means LVO is the chemistry chosen for a next generation, let's call it early production platform, whether it's in mining, construction, or trucking, that could then lead to on-road demonstrations with customers in their proving grounds or in the corporate, essentially, sort of demo and prototype trial platforms that could then lead to commercialization. We believe by end of decade, right? So these are about 12 to 24-month type of sales and demonstration cycles. And we want to be part of that roadmap so that by 2030, we can be on production platforms or early production platforms in these, beachhead markets, right? Defense, heavy industry. And then beyond 2030, you're looking at now, we believe, the world of physical AI.
Yeah, that's good timing. Thank you. Next question. How do these batteries compare to newer generation sodium ion batteries that will be deployed by CATL for long haul trucks and low temperature ESS?
Yeah. So, um, at the end of the day, we believe the platforms um, that require high uptime, right, will require the whole suite of operational requirements. Essentially, energy that meets or exceeds where you have today in order for you to get that range. And then all the other uh, fast charge capabilities, low temperature capabilities, high power capabilities. Sodium ion has some of those, but at the end of the day, sodium ion is still a low energy system. So you're actually going to significantly get penalized on range and potentially on charging time as well. So we believe LVO is still that, let's call it, premium performance platform. Now, we may not win all the market, but as I showed you, the market opportunity is huge. And even taking, a few percent, literally single digit percent growth of that overall TAM could more than triple, right? The overall vanadium production output annually.
Good. Next one. How does an LVO anode lithium ion compare to battery swapping of an LFP and of a semi-solid state battery?
Yeah. So once you start doing battery swapping, at the end of the day, we believe at scale, the cost of those two battery swaps, plus the charging infrastructure, plus the management of essentially all those spare battery packs, will be a negative relative to a single battery that LVO can essentially charge with. And oh, by the way, here's another really interesting future, sort of, let's call it roadmap we see. Fast charging can now actually enable what we believe is rapid on highway or on road or on route charging, right? You've seen this in mining applications where they have overhead electric wires or third rail type of systems. In a system like that, why do you need to swap? Electrons can be distributed along essentially your roadway or your pathway. And with fast charging, in a few minutes, you're back to full state of charge. You actually have a better operational uptime and capability with a fast charging system than doing the swaps. So we believe economics will bear out, right? This particular use case, and it's already being essentially trialed, for example, by Caterpillar and others in some of these prototype mine systems that we see today.
Here's a question that I've been wondering about as well. What kind of purity levels are needed for the vanadium in your systems?
Great question. Industrial grade is what we're seeking,
Okay.
98% or better. So this is not your 5 nines requirement, for example, in VFB, because of those let's call them side reactions related to iron or other contamination can lead to hydrogen generation. This is an LVO anode that sits at near 0 volts relative to lithium. It's so reducing that essentially any of those impurities are stuck in the material itself. So our goal is to use what is currently made in industry today, 98% or better, industrial grade V2O5, although we do need specific particle size requirements, about a micron or so sort of particle size, which fits into the lithium ion battery manufacturing ecosystem.
All right. This is sort of a longer one here. As Tyfast moves from pilots to commercial deployments, what is your strategy for third-party validation, warranty backing, performance guarantees? In other words, in your view, what will be required before lenders, insurers, and industrial customers can treat LVO as a financeable industrial technology rather than just an emerging innovation?
Yeah, so I think of that as TRL, MRL, and then essentially bankability. So we need to get TRL to essentially an 8, which is, in my opinion, multiple packs out in field validated, right? MRL up to, let's call it an 8 or 9, which means we're producing this material at double-digit megawatt hours, triple-digit megawatt hours. You're looking at essentially from our perspective, double-digit millions, under 100 million dollars of investment required to get to actually that scale. Beyond that point, we believe we are now bankable, financeable. And in fact, um, from a national security defense standpoint, we believe the traction we're getting now from Army, Air Force, Defense Logistics, and others could potentially allow us to get to that scale with some of that financing provided by, for example, the Pentagon or Department of Energy.
One more question, real quick here. What
Yep.
is the cathode chemistry, and is this
Mhm.
electrochemically limiting over the LVO anode?
Great question. We use standard NMC type cathodes today. You also use LFP. The answer is it just needs to be tuned for rate and life match. Some of those cathodes are high energy cathodes, very thick. They have low rate, in some cases also low life. We would have to just tune essentially the material. So it's not a change of material, it's a tune or engineering of the electrode to allow you rate and life match to basically get the most out of that combined LVO standard cathode pairing. So we are cathode agnostic. It just needs to be engineered for rate and life matching.
Great stuff. Very exciting developments. We're always been watching this carefully here at Vanatech. We appreciate the presentation. Will you be able to stay on for the rest of the webinar today, or do you have to run?
I do have to run after Terry's, but I'm happy to connect with the Vanitech
Yeah.
members. My email is there. Feel free to reach out and happy to set up a separate call with you.
And
Thank you.
if any of you have another question for GJ while he's still on, you can
Mhm.
put it in and he can monitor the Q&A and maybe an answer one. You can type it in answer as well there, GJ. If someone else has another question. Great.
Absolutely. Thank you so
Thank you very
much.
much.
Appreciate it.
Wonderful. Appreciate it.